have you if you're going to sit the exam or not? Maybe? Huh? Try to do the pilot exam on the revision kit. There's a okay, then you'll get to but you have to keep yeah. No, no, not that one. There's a pilot paper there. That's an example sample question. Okay, so how is it? Were you able to answer? Okay, so how much do you think you know of it? Okay, so how is it? Okay. It's good enough. But you have to try it more. I'm in practice more. Yeah, but generally, if you're studying it, it's okay. Why not? Maybe. Everything is a maybe. Still worried about that. We want. Alright, everybody, I need you to open your computers now. We're going to start. And we're going to review linear programming first. Okay? You remember? We talked about in linear programming, we needed to learn how to translate the problems into equation. Remember? Okay? So I need you to be able to do that. First and foremost, those who were not here last time, I have the handouts from chapter 4. So you may want to get a copy. Okay. Did I give you the copy of the linear programming technical paper? Yeah. No. This is linear programming technical paper. Not yet? Not yet? Okay. Alright, so I'll give you this one now. This one is linear programming technical paper, although this is in the Google Classroom. Did you see this? Yes? Okay, but this is the hard copy. This is chapter 4. We're going to do practice of linear programming questions. Okay? Linear programming questions. So, I need you to bring out your computers so that we will learn how to answer it on the screen. So this is the first thing we need to do today. We're going to, okay, very important. I need you to be able to work on linear programming questions. So the first step is review of okay, so I need you, we need to do two things. We need linear programming, so also, okay, and we need to look at, that's one. Number 2 is shadow price. You remember the last time we spoke, we talked about shadow price. So we have 2 class activities. One is just to practice how to put into programming our problem. And second, I have an exam type question for you to work on. So 2 things. Okay? Second half of our discussion, we go to the next chapter of pricing, of decision making, which is chapter, what chapter is this now? Chapter 5, which is on pricing decisions. Okay, pricing decisions. All right, so that is our program for today. In the meantime, I'm giving you the handout of the technical paper. Okay, the technical paper is about linear programming. Okay, linear programming. All right. Take your computers out. I want you to go into Google Classroom so that you can open the problem of our exercise from there. You didn't bring? After what? And then we sent you email to bring your computers. Who else doesn't have the computer? Who else? You. Anybody else? Okay, it's good. Next time I need you to bring, huh? Okay, please. Otherwise we will not be able to make it. Okay. I will not be able to practice and it's not going to be good. It's good I have a backup system. I have it printed. Not for everybody. No. Those who have computers must work on the computer. No. Not there, huh? Okay. But please, if you brought your computers, I need you to type on your computer. Can you do that? Okay. But I'll give it to you as a handout here. Wow, thank you. I always have to be a backup with you, no? You guys. But please, those who brought, please practice that on your computer, please. It's coming. Which one is that? Chapter 4? It's coming. Anyone? It's coming. Everybody wants a copy. That is chapter 4, and you have to have a copy of the technical paper. Here it is. Okay. Now, also,
so nice to you, I also give you a piece of paper to work on. Isn't it? Here. Okay? Alright. Okay. Okay? Now, for those who have your computers, go to the Google Classroom and open what I posted as an activity today. So, go to the Google Classroom. I ask you to open this document. Okay? Alright, there's a document like this. Do you see it? Yes. Yeah, this is what exactly your handout is, right?
Yeah.
Okay. So, what is the first requirement? It says, read the requirement, please. Now, it says, formulate the objective and constraints. Okay? What is the first procedure for linear programming? What is the first step? You remember? What was the first step? You need to define the what? Define the what are the variables? You remember? Okay. The first step was, I will write it here, although it's not part of the answer. The first step is define the variables, correct? Okay. What are the variables? What is it asking you here? The company uses linear programming to establish, now it's very small, you have a piece of paper I gave you, right? Read from there. Okay. Establish an optimal production plan to maximize profit. So that is the objective, maximizing profit. Okay? The company finds that for the next year, materials and labor are likely to be in short supply. Means what exactly is that? Means material and labor are, what's the word? Are the constraints. You understand? Are limited. Okay. So, the company has how many products? 2. Which means, with the constraints, they want to establish optimal production plan. What does it mean, optimal production plan? In other words, you need to establish how many of what? How many of A to be produced and how many of B to be produced. So therefore, what are your variables? Your variables are A and B, correct? So, your variables therefore, so that everybody will be in the same wavelength, is that we want let A equal to the what? Be the number of units of product. What product is it? Product A to be produced, correct? Yes? Okay. Alright, let me, then what is the other variable? Let B, small b, be the number of units of product B to be produced, correct? Yes? What is it asking you to do in letter A? Formulate the what? Okay, objective and the constraints, correct? Yes? So, what will you do? Can somebody tell me what should I do? Okay, so letter A. What is our answer for letter A? What is the first constraint? What is the first constraint? What is the first that is not enough? Look at the problem. Don't look at the board. The answer is not on the board. The answer is in your piece of paper. What is the first problem? What is not enough? Materials. How many kilograms of materials are available? Okay, can you tell me? So they can use only up to 30. 30,000. Where should they go?
Below.
Well, I don't know. Where's the problem? This is the problem. Okay. Alright, you have to be with me, huh? I need you to work. Now, how many kilograms? 30,000. So, what is your constraint function? What do I need? What information do I need of A and B? Okay, so first, let's talk about material first. What is the equation? Remember, A is the number of A you need, and B is the number of B. Tell me what is the equation I will write.
6 times 2, 30,000. 8. What's the equation?
Yes. I need the equation for materials. What is my equation? 6A plus? Excellent. So 6 is 6 kilograms? Are you sure?
No.
No.
5.
That is price per? Is this price per kilogram? What is that? Material price per product A, correct?
Yes.
Is that what I input? I only have 30,000 kilograms of material. What is the equation? What information do I need? What is information I need? The number of kilograms that is needed to make A, correct? And the number of kilograms to make B. How do I find it? It says product A is $6 per unit of A, correct? How much is per kilogram?
$2.
Which means how many kilograms I will use for A. Oh, okay. Now give me the equation. What is the equation now? What is the equation?
That's mean $6 is the price per unit.
Yes. Price of product A. The material cost of product A. Yes, sir? $6 and $8. These two means that it is the material cost of each of the products. But the material per kilogram is $2. Where did I see that? It's here. Correct? You see? Alright, now tell me, what is my equation for materials constraint? Okay, materials constraint, number 1. What should I write? Okay, materials constraint. Okay, can I remove the problem? The problem you have a copy, yes? Yes? I want to make sure I have this one. Yeah, this is better, right? Okay. So material constraint is what? 3A. Yes, agree? Okay, so 3 kilograms, you understand? Okay. So, alright. Plus what? 4B. Does everybody understand why? Yes? Okay. Alright, so equal to, I don't know if there's equal to here. Yes, there is. Okay. So, greater than or equal to, correct? Sorry. I have what? 30,000 kilograms. Agree? How, again, for those who are not following, what happened to A? A says the cost per unit is what? 6 kilograms for material, correct? Divided by what? Divided by US dollars 2. So, which means that is what? 3 kilograms, correct? Yes, okay. And then, what about B? B says, okay, US dollars 8. Again, per kilogram is 2, which means how many kilos? 4 kilograms. You understand? Get there? Okay. You see that? Sorry. Wrong. Yes? Okay. Now, how about the other constraint? Okay. Tell me now about labor. Labor. What about labor constraint? How should I write it? Okay, so labor. Alright, so let's see first labor. A. How much is the total labor cost in your problem? It says 30? 30, no. How much is the labor cost? Per unit, correct. So labor cost of unit product A is 30, correct? How much do they pay per hour? Okay, per hour is $6. Okay, which means how much per hour? Okay, so $5 per hour. So this one is 5. Sorry, 5. You said $5? No, sorry. 5 hours, not $5 per hour. 5 hours, okay? How about B? US dollars. How much is the total US dollars? 18. Okay, divided by, again, per hour is $6. So how much? How many hours? 3 hours. Yes? Give me the equation. 5A. Is everybody following? Yes? 5A. And then plus 3B. Correct? Yes. Yeah. See? Okay. So you can follow. I need everybody to follow me, okay? I need you to be able to do it. I'm not going to get you out of today unless you know this. Okay? You come home with me. Okay? Alright. So everybody's on, you're okay? Where's your paper? It's at the back here. Please. Let me make some. Give me the equation. 5A plus 3B. Okay, so less than or equal to how many hours do they have? Sorry, what's wrong with me? How many hours only available? It says? Okay, 36,000 hours. Yes? You understand? Got it?
Yeah.
Is there anything else? That's all? Are you sure? You see? There's something missing. What is missing? What do you call that? Oh, very good. There's one more. What does it say? There is an agreement, a contract that says that product A has to be 1,000. So, which means You have to at least sell 1,000, correct? So is that a constraint as well? Yes or no? Is that a constraint? Yes, it is a constraint. What do you call that? Okay? You call that a minimum supply, correct? Okay? So minimum supply of product A. What is your formula? What's your formula? So it says, well, how many units it says? Okay, so what's your formula? Minimum supply. Translate that into an equation. So A should be what? Should be? Yes, very good. Yes. So A, small a, is greater than, correct? Or equal to how many? 1,000 units. Yes, yes. Okay. Anything else? Is there any other constraint? Can I sell -5 of A? Can I sell negative of something? Can I produce negative of something? None. So what do I call that? What is that called? None? Yes, that's called non-negativity. Okay? How do I write it? How do I write non-negativity? A. No, but A is already greater or equal to 1,000. So, we already have that. We know we cannot have less than 1,000, correct? So, which means my non-negativity will only be what? B, correct? So, B should be what? Greater than or equal to what? 0. You got it? The A is already greater than equal to 1,000 even. Yes? So the one that is non-negativity remains only B. Got that? Anything else? So all the constraints are there. Look at the requirement of A again. It's only constraints is asking? What is else is asking? Sorry, wait. You okay? You following? Yeah? Everybody following? Yes? Question? No? Okay. Now, is there anything missing in requirement A? Look at requirement A. Is anything missing? No more? Are you sure? Constraint is there? So the objective function is missing, correct? So what is the objective? What's the objective? To what? What do they want? What do they want to achieve? Maximize what? Do we have profit? What does it give us? Contribution. So we can, of course, when you maximize contribution, you maximize profit, correct? Contribution is given, right? So let's look at the objective function. The objective function would be, okay, so give it to me in formula. That is why it's linear programming. Tell me, what is the objective function? You want to maximize contribution. Tell me, what is the formula? 9A. Where's 9? Do you see 9 somewhere? Yes. 9A plus what? What? 9A plus 23B. Yeah, oh, it's okay. Where is it from? It's there. Yeah, okay. Alright? Yes? Agree or disagree? Are we all on the same page? Okay, you understand what happened? Okay, good. How about you? Yes? Okay. At half? Okay, now, what is B? What is requirement B? Requirement B. plot the constraints into the, okay, now remember, how will you plot the constraints? A and B, correct? Okay, so A and B. So one of the equation is A and one line is A and one line is B. All right? Now, of course, in the exam, they will not ask you to plot, correct? They will not ask you to plot the constraints. They will give you they'll give you the what? The chart. So I'll give it to you now. Okay? So I'll show it to you. Hold on. Let me just get it. Alright. So, here is, okay, okay, what do you see? Can you interpret for me? Can you interpret this for me? What is the horizontal line? It actually is A, correct? And what is B? Is the vertical line, correct? Okay. First is, there are three constraints, yes? One is the material constraint, second is the labor constraint, and the third is the minimum. Do you find it? Can you find it? Which one? No. I'm not talking about the optimal plan. That's the solution already. Okay, which one? Which one is, so it says here that one of them is, I'm not sure if I can write. Okay, so which one is the, okay. Let's see if I can. All right. Which one is the kilograms? Which one is the kilo? Which one is materials? Materials is 30, correct? Okay. So this is the line. How did we get the line? How did you plot this? How do you think they plotted it? If A is 0, what is B? Calculate. If A is 0, so which means A is 0, correct? What is B? 7,500. Do you understand? Okay. So if A is 0, B would be 30,000 divided by 4, correct? It's 7,500. So that line is my materials line, correct? Okay. Because if it's B is 0, what is A? If B is 0, so this is 0, A would be 30,000 divided by 3. So is that correct? 10,000?
Yeah.
Yes. So which means I can put that line, correct? Yes. Okay. How about the labor? You see the labor? This is your labor, correct? Okay, let's see if it's correct. If A is 0, yeah, what is B? 36 divided by 3 is what? 12, is that correct? 12, so 0.1. Yes? How about if B is 0? B is 0, what is A? 36 divided by 5. So how much is that? Is 11,000? Is that correct? 11,000? No, sorry. 7, where are we? Sorry, 7,000 something. Correct? Okay, so somewhere there. Alright. Now look at the third constraint. There were 3 constraints, correct? What was the third? The third was A should be 1,000 or more, right? 1,000 or more. Okay, so what happens now? So that is your chart. Well, what is the solution? What is the solution? What is this line here? How did they build this ISO profit line? You remember? So let's see. You remember ISO contribution line. Okay? How did you build that line? I'm trying to see how I can convert that to my hold on guys. Relax. Okay, here we go. Ha! Magic. Alright. Again. I will repeat for you, okay? So the first line is... Where are you, ruler? Did you bring your ruler? I know you did. Okay. Alright, so the first line is our... Okay. The first... Which one is this? This is our... So the blue line is your, what do you call that? What is this? Your materials, correct? How is the 2 points here? If A is 0, B is what? B is 7,500, correct? If B is 0, A is what? 10,000, okay? How about this? This, the red one is what? Put it a red. Is your labor constraint, yes? Okay, so this is your labor. And the labor is, if A is equal to 0, B is what? B is 12,000, is that correct? If B is 0, A is equal to something, what is it? 200, okay? Now, the third constraint would be what? The minimum constraint, correct? Okay. So, what is the feasible area? Where is the feasible area? Okay, remember the feasible area is within the what? Within, is this feasible? Yes or no? Is that feasible area? Is the yellow line there feasible? In other words, can this be the solution here? No, why? Because it's not within the material, correct? Okay, how about here? No, because it's not within the labor. Okay, how about here? This small area here? No, also, because it has to be minimum 2,000, correct? Yes? So, the yellow line I drew there is not feasible. So, which one is feasible? Okay? Which one is feasible? Is this feasible? Yes or no? Yes, which means the answer can be any one here, correct? Any combination will give you a profit and is within the constraint. But the question is, what is the maximum, correct? What is the maximum profit? So what did we say? We have to draw an ISO contribution, correct? Yes? ISO contribution. What do we need to draw? How do I draw that? Which function do I need to go and use? I want to maximize profit, right? Yes? So what is the combination of A and B to maximize profit? Right? So what function do I use? What formula? So we need to go to the contribution, correct? So what is our contribution? What is our formula for contribution? Can you tell me? Is equal to 9A plus 23B. Now what did I tell you? To draw that line, I have to assume what is the contribution, correct? Okay. So what could be the any number? So for me, I will multiply 9 and 23, correct? So 9 and 23 is how much? How much is 9 multiplied by 23? Any number, you can have 100,000, it doesn't matter. But I want to know where do I start? So usually I start with the given information, yes? So 9 multiplied by 23 is how much? 200 and, okay, so let's try 207. So 207 equals 9A plus 23B. So if A is 0, what is B? 9, of course, okay? But remember, this one is in thousands. So if you draw the first line, it will be so much, not possible, no? Yes? So, what should I do? Maybe I add 1 0. So not this. Let's do another one. Yes? I add 1 0. Okay, so if A is 0, what is B? 90. 90? Remember, these ones are in thousands, yes? So still very small line, correct? Okay, then we add another 0. Okay. So 20,000, 9A plus 23B. So remember, I want that ISO line, correct? So let's see. If A is 0, B is what? Oh, 900. That's cool. But then, if B is 0, what is A? What is it? If A is 0, okay, so if divided by 9 is what? 2,300. Can I do that? Yes? Okay, fine. We can do that. If A is 0, B is what? 900. So somewhere there. Yes? Okay, let's see. You try that. We can do that. And then the B is what? If B is 0, 2,300. So somewhere here, correct? Very small. But you can do, if you like, you can do that. Okay? So, alright. So what do? I go parallel, correct? Yes? Parallel. And of course, because it's not exact. So you actually, it's parallel to this line here. So it goes up and goes up. Can we go further up? Yes. Are we reaching the end of the feasible region?
Not yet.
Not yet. So I can still make my line go up and up, correct?
Yeah.
Okay, so goes there. Alright, so it's not yet touching the end of the feasible region. So what happens now? Do I stop? Am I at the end? No? Not yet, right? Okay, so I need to go further up. Okay, so let's see. Alright, is that the end of the feasible region? Yes? Alright, so where is that end going? You see where it says optimal plan? Yes, optimal plan? What happened there? Optimal plan is here. Means what? Optimal plan means A is what? A is equal to 1,000 and B is equal to 6,000 somewhere, right? How do I know exactly? What should I do? So how will I solve it? How do I know what is B? Because it's not very clear, correct? What can I do? Solve the what? Using, what did I teach you the last time? Solve it using simultaneous equation. Remember simultaneous equation? But which two equations? Yes. Why did you say that? Material and labor? Are you sure it's material and labor? Which two lines are crossing? Which two lines is in the optimal point? Is it labor and materials? No. What is in that? Minimum supply and, oh, okay. So if that's the case, if I solve it, there are two. Tell me. There are two equations in that optimal point. So I will show you optimal point. Okay? So the first line, you see down the line? Yes, the first line, that intersection is 2. 1 is your optimal. And what line is this here? Is your materials line, correct? Okay? So, let's solve it. So, A is equal to 1,000, it says. What about the other line? What is the equation? Sorry, I cannot see. 3A, okay, sorry, put it here. So, A is equal to 1,000, and the other one, it says 3A plus 4B should be what? 30,000. Yes? So which means I already know that A should be equal to 1,000. Can I solve B? Yes. All I need to do is say 1,000, okay, plus 4, I don't know, right, is equal to 30,000, which means what is B? B is equal to 6,750. Now look at your chart. Is it 6,000 plus almost 7,000? Yes? Okay, so to be precise, then the optimal point, the optimal plan is what? To make how many of A? 1,000 of A and 6,750 of B. You understand? Yes? Alright. Sure. Okay. Okay. Sorry, optimal plan. Yes? Yes. Mhm.
Here go one cross, here go one cross. So why is this called
Yeah, because I have my ISO profit line. My ISO profit line is based on my contribution. It's not just any edge. That's why you have to put the ISO profit line. Where it is touching the last of the feasible region, that is your optimal point.
we have to take higher weight?
Yeah, because if you move, you don't stop here. Because if you stop here, it's not yet the end. There's more space.
Because it's higher, we have to take this.
No, it's not because it has, your ISO line has to reach the end of the feasible region. You understand? You have to move until this line falls to the end of your feasible region. Do you understand? You just don't stop anywhere. Yes, it can be a solution, but it's not the optimum. Remember, they want to maximize profit. Okay? Now, what if you don't have the chart? Or what if you don't like to solve using the chart, ISO profit line? What can you do? You may have to use simultaneous equation on all points. How many points can you solve? 1. What we did. Where's the second one? This is the second one, correct? Which two equation is here? Material and labor. Once you find, and sorry, there's one more here. Which two lines? Labor and what? Labor and A would be what? 0. A is 0 and labor cost. You understand? Okay. So if you don't have, you have to calculate all the possible points if you don't want to use this line. Yes? Which answers your question. Why not the other point? Okay? You can use the ISO profit line to determine which point is your maximum, or solve all the connections, all the possible endpoint.
If we don't have this constraint, will this be the optimal one?
Well, depends.
Without this,
Which one?
without this line. What is the constraint for it?
We don't know still. Because if that's not the end, the tip of your constraint is up here. The tip of your constraint, it will be here. Still, that is still the end. So B probably will be 0. You understand? Okay, her question is, if I don't have a minimum constraint, would this be the point? Looking at this, no. Because then the feasible region will include this. That will be the tip. If you move the ISO line further up, you got that? Okay. So it really depends on that. Okay. Now, again, if you don't have the ISO line, what would be the feasible region? What would be the optimal solution? How will you do it? If you do simultaneous equation, I would try 1, 2, 3. Then I will have 3 combinations of A, B. Now how do I choose which one? I have to put it on the objective function. What is the objective function? Do you want us to try? I'll show you. Let's first put this one here, so you will see. So if this is the optimal point, what is the contribution if I use the optimal point? Can you tell me? 9A plus 23B. So 9 of 1,000, correct? Yes, everybody?
Yeah.
Okay. Plus 23 of A. Yes? So how much is this giving us? How much is this profit? What is it? 100? 164,250. Okay? Understood? Now, would you like us to try those 2 more points? What were the 2 points more? Let's try this point here and this point, correct? So you have the optimal plan. You have then, how do I say this? Option 2 And this one would be what? Option 3, correct? Alright. You want us to see which of these three has the highest? Yeah, and I just proved to you that the optimal point is where you're going isoline. Okay, work with me. Okay? Work with me here. Now, option 2. Which 2 points? We said. Option 2, which 2 lines? Okay, so let's see. 3A plus 4B is equal to 30. What was the other line? 5A plus 3B is equal to 36,000. Okay, so how do I eliminate one? Minus one from the other. Yes? What should we do? Can I work on this? Yes or no? Which one? Which one I multiply by 2? 3? So will it eliminate one of the A? You want to eliminate B? Yes? So what will you do? By what? 4. In the top, we will multiply by what? Multiply by 3, correct? Okay, so let's see what happens. So this will be what? 9A plus 12B is equal to 90. Very good. The lower one would be what? Minus 20A, is that correct? Plus 12B is equal to that. Everybody's following? $144,000, correct? Okay? You know what I'm doing, right? Okay, so which means now, what happened? Negative what? 11A equals negative negative what? 54. So therefore A is what? 4,909.09, correct? Okay, so if that is A, what is B? 4,909.09, correct? Plus 4B equals 30,000. So what is B? So you know that A is this, B is what? Can you calculate? $3,818.18. Yes? Okay. Because you didn't count. Okay. Now, let's see. Constraints, objective. Yes? I want to know if this combination will give me maximum profit. You understand? Okay? So, 9A plus 23B. So, 9 of 4,909.09 plus 23, 3,818.18. What is my contribution? $131,999.95. Okay, compare it with the previous one. Is this higher or lower? What was the first one that we did? 164. So this point is not optimal, correct? It's a possible solution, but not the maximum profit it will give. You want the third point? Let's try the third point. The third point is easy. What is the third point? Option what? Option 3. Tell me what is option 3. Option 3 says that A is equal to what? Look at option 3. What does it say? A is what?
72.
Is that an option? A is what here? A is equal to 7,000. What did you say earlier? 200. So A is 7,200. Yes? And what is the other equation? What is that? Labor. What is the labor equation? Can you give it to me once again?
5A.
5A plus 3B is equal to 36,000. So you know what is A. What is B now? 5 of 7,200 plus 3B is equal to 36, correct? So what is B? B is 0?
Yeah.
Okay, so B is 0, you said. Is that correct? Okay, so good. Then, calculate for me then. Contribution is equal to 9, how many of A? 7, 2 plus 23 of 0. So what is that amount? 64,800. So, out of the 3 points, which one will give you the maximum? First one. Okay? So, it's either you use the ISO line to get straight to the point, or you calculate all the points, possible points, correct? Possible end point of every piece of the feasible region. You got that? Okay. Right? So it just proves to you that if you put the ISO contribution line and move parallel up, it will give you straight to where it is a maximum, the optimal solution. You understand? Okay? But if you don't have that option, you can solve each point. You still come up with the same solution. You got that? Okay? It will still give you the maximum. Got that? Okay. Alright. What is letter A? I want you to give me shadow price. But first, before you go to the shadow price, what is letter C? Slack? Okay. Tell me, what is a slack? Slack is when? Slack is when you use what? All. At maximum, at the optimal plan, you use up all of your constraints. Again. Slack, yes, no, that is binding. Slack means that when you have optimal plan, you will have extra of the constraint, of the material or labor, correct? Okay. So, the question is, you have 2 constraints. What are the 2 constraints again? Material and labor. Tell me, which one is slack? Which one is binding? What is the word binding? Binding means all of the constraint is used. You understand? All of what is not enough is used. That's binding. What is surplus? Surplus means if you make more of something that is minimum, correct? Yes? What is the minimum constraint here? The 1,000 of A, correct? Now, in your solution, do you make more than 1,000 of A? What is the optimal solution? Don't look at me. It's in your paper. What is it? What does it say A? 1,000. A is 1,000, correct? So do you have a surplus? Do you have a surplus? No, because you did not make more than the minimum, correct? Oh, good. But do you have a slack? Can you answer me now?
No.
No. What will you do to tell me which one has a slack? The materials or the labor? What will you do? How do you know? By looking at it, see, your computer is magic, huh? It's not even there. Out of the solution here, how do you know which one is slack and which one is binding? Because there are only two you have minimum of, 36,000 or maximum of 36 labor and material, correct? So tell me, which one do you have slack? Which one do you have more? What will you do? What will you do? Okay, you know that you have the optimal plan. What is your optimal plan? Which one was your combination that give you maximum? A is equal to 1,000, very good, and B is equal to? Okay, now, you know how many you need to produce, correct? Can you tell me, with this number of A and B, will you use all the materials? Will you use all the labor? Can you find out? How will you find out? You know you have an equation, correct? You have the equation of material. What is your equation for material? Yes. Can you put the number of the A and B? Can you see if you use all of the 30,000? Come on, solve it. Don't look at me. Come on, guys. How many of, if I make 1,000 of A and 6,750 of B, will I use all the labor and will I use all the materials? Yes or no? Double check. Yes, you cannot answer me unless you compute it. Which one? What is the material? 3A. So, materials is, I have what? Okay, so you have 3A plus 4B. Is that correct? Okay, should be equal to 30,000. Let me see. 3 of 1,000 plus what? 4. Plus 4 of 6,750. How many does it give me? So, okay, so it gives you, yes, 30,000. So, have you used up everything? Yes, so what do we call this? This constraint is called binding. You used everything of what is available. How about labor? Will you use the same thing? Let's see. What is the, sorry, can you give me the labor 5A plus, okay, 3B should be equal to what? 36,000. Let's see. 5 of 1,000 plus what? 4 of 6,750. Sorry. It's 4? No, sorry, 3. Sorry, guys. 3. Okay. How much? 2,550. Okay. Which is, does it use everything? So what do you call that? That is called a slack. Means you did not use all what you have. Yes? You did not use all that you have. This is called slack. Yes? Slack. Why again is slack? Because you have 36,000 hours, correct? With the optimal plan, this is your optimal plan. You only use 25. Then you have a slack. Understood? Okay, there's one more question. It's not binding, correct? Sorry? No. Surplus is, this one is a maximum constraint. Surplus is on the minimum constraint. Surplus is when you actually use or make more than the minimum. What was the minimum? But the minimum was A, correct? Did we make more than 1,000 of A? No. So there is no surplus. You got that? No surplus. Okay, let's answer that here. Okay? Alright. What about surplus? No surplus. Why is there no surplus? Because we have not made, or the company did not make more of A, which is product A, which is the minimum constraint. Okay? There is no surplus in this story. Okay? Question. The last requirement there is supposed to calculate shadow price. What is shadow price? Shadow price is when you have to determine what is additional contribution if you had one more material, correct? But which one will you have a shadow price? The material, the labor, or both? Very good. The materials will have a shadow price. Why not labor? Because labor you still have number of hours, correct? Okay. Why will I buy additional labor hours when I have extra hours? You have a shadow price only if your constraint is binding. Again, you will have a shadow price if your constraint is binding. You understand? Which means if I want to buy something, I will not have to buy labor because I have extra labor hours. You see? What I want to buy is materials. Another kilogram of materials. So, how do I calculate shadow price? What did we do? Yeah, you have to add 1 more kilogram of material. Okay, so let's calculate shadow price, shall we? Okay, shadow price, letter D. Price will only be for what? For materials because it is binding, okay, at the optimal plan, production plan. Okay, so what will I do? So A will be the same, correct? A is still 1,000, right? Is that correct? How about materials? Because remember, those are the 2 lines, correct? That together. Material, what is the formula of materials? Okay, so remember, materials is, okay, 3A, plus 4B is equal to, how many do you have now? 30, material? 30,001. You have 1 more kilogram of materials. Okay? So, how do I know what is the optimal plan? So what should I do? So, since we know what is A is 1,000, yes, plus 4B, yes, which is B, we don't know, equals 30,001, which means what is B? B is equal to, how many? 6,750.225. So now you have 2 combinations now. Your A and this is your B, correct? What should I do next? Now I have, remember earlier the combination was 1,000 and 6,750, correct? That was the original. Now it's 1,000 and 6,750. What should I do now? I go and find the new contribution because I have a new combination. C is equal to 9A plus 23B. Yes? So, what is the answer? 9 multiplied by what? 1,000 plus 23 of how many? 6,750.25. So what is my new contribution? New contribution? How much is the new contribution? 164,255.75. Okay, good. So tell me, what is the shadow price? What should I do? How do I know what is the shadow price? Yes, this contribution minus the optimal plan contribution, correct? Okay, so what is this now? Tell me. So I'm going to take this one, 164,255.75 minus, what was the original? 164,250. So what is this? How much? 5.75 is the shadow price. Yes? Shadow price. Which means with 1 kilogram of material, I make additional what? Additional 5.75 of contribution. This is a contribution, correct? So I make 5.75 of contribution. Which also means, how much am I willing to pay for 1 more kilo? Sarah, how much? Wrong. Again, I will ask my question. I will buy 1 more kilo, right? Is that material? Yes. This is material we're looking at, right? Materials, correct? Yes, you added 1 more kilo of material. How much is the maximum price I am willing to pay? There you are, 7.75. Why is that? What was the original material price? Original is $2, correct? Okay, shadow price, which means this is your what? What is the other meaning of shadow price? Is your premium you are willing to pay, correct? And how much you're willing to pay premium? We said 5.75. So maximum price you are willing to pay, okay, for 1 kilogram is what? 7.75. You understand now? Yes? That is what shadow price is. Because with 1 kilo, you are able to what? With 1 kilo, you are able to increase contribution by 5.75. That is how much you can pay extra. Because then you will just break even, correct? Yes, if you want 1 more kilo. But if the kilogram will ask you to pay $8, don't buy it. It's not worth it. Do you understand? Your overall profit will decrease. Okay, you got that? That is what it means by shadow price. The shadow price is not the maximum price, it's the premium. Okay? Understand? Question. I'm going to give you now a quiz and see how many will pass. Okay? I think the other one. Here. Here is the answer with the graph. Okay? Oh boy. Oh boy, boy, boy. I really need to make sure that we practice one more time. Okay, listen. As soon as you pass that answer, I need you to work on something when you come back from the break. Is that okay? It's a little bit slower than I expect, but I want you to be able to answer the next question. Okay, where is my next question? Okay? Your next question is in your Google Classroom. Okay, so I don't have it printed. Sorry, this one is unexpectedly not there. Okay? So, alright, so when you come back from the break, alright, we will do another exercise to find out about shadow price and doing the constraint. Got that? Okay? I want you to master this before we do the next. You? Okay? Okay, take a break. I need a break. Okay, go and in 15 minutes come back. We do another one. We do another one. Okay? Question. What's the question? Ask me. Yes. What is the price? What is the price? 2. Okay. Now, if I add 1 more kilogram, it will give me 5.75 of contribution. Yes? Okay. So, which means that is the contribution it gives me. So if I want to buy 1 more, I can only pay the original 2. Now remember, if there is something that is not enough, means the price in the market will be very high, correct? Okay. But up to what price am I willing to pay? Because they can go as high as they want. But for me, in my company, I can only pay up to 7.75. Because if I pay for more, then I will already become negative here. You understand? Got that? Now, because remember, if something is not enough in the market, if supply is short, what happens to price? Very high, correct? But as a company, in this case, this is how much I can only pay. Because it depends on my situation, isn't it? So if somebody is selling me at $8, I'll not buy. But if somebody is going to sell me at $7, will I buy? I may not get additional $5 contribution per kilo, but at least I can get 75 cents per more contribution. Okay? Even if it goes 7.76. Will I buy? No, because 0.01 multiplied by 10,000 kilograms is still $10,000. You understand? Or $100, whatever you call it, multiply. You understand? Got that? You ask me, don't be shy. Okay? Okay, let me look for my other work.
Before that, I go to the toilet. Otherwise, I'm like, Can you access my Google Classroom? Can you access my Google Classroom? There is one under PDF under performance management. I have just posted it up here. So can you print me, make copies for my class now? Can you make it up? Can you see it? And the title of the company is Cut and Stitch. Cut and Stitch. Yes? You see it? Cut and Stitch. Call me if you didn't see it. Okay, it's a linear programming exam question practice. Cut and Stitch. Other people's premises? It is. That's yours. It's on consignment. It belongs to who? Yours? Then it should be in your inventory. It's your inventory. Check. You send a confirmation letter. You send a letter to whom you gave the inventory to count at the same time you count your inventory. Say, they let them count. It depends. If you find it material, then you probably need to send a thing. But it's not material, then you just need to justify. Right, very good. Go to your Google Classroom and open what I just shared. This document would be on your screen. Now, for those who don't have, wait a minute, I'm getting some on top of the paper. Open it up, please. Open your Google Classroom. I just shared this document with you. Can you open it? Were you able to open it? Is it there? Yes, good. You're my baby. You're fast. Okay. How about you? Do you manage? Let's take it. It's very small, huh? No, right? Okay, you can go expand, yeah? Okay. Alrighty. Okay. How about your phone? Can you access Google Classroom? Try. I'm coming with the hard copy anyway. Okay, I hope they were able to make copies. Alright. Let's look at down below, please. Requirements. What does it ask you to do? Calculate the what? Optimal production plan. Calculate. Okay? That will what? Maximize contribution, correct? Okay? And what is the second requirement? Shadow prices of fabric and tailor time per hour. Okay? The shadow price. Alright. What is given? Alright? So read first. So since it's on the screen or whatever, you can, is it big enough? Okay.
first one. Okay. How about it? Right? All right. Do you understand what is given? Yes, based on what we did earlier, this is easy to understand, correct? Which means they are making suits. So W is the number of work suits, L is the number of lounge suits, right? And what are these two here? Tailor time and fabric time. These are the two constraints, remember? So which means how many hours of labor do they have? 3,500, okay? Very good, fantastic. Okay. So for those who want a hard copy, the old way, but this one cannot get rid of paper, isn't it? Okay. What does this mean? What is the third line here mean? Can you tell me what this means here? It's a minimum constraint, correct? Which means whatever they do, they should make at least how many? 400 of the work suits, right? Understood? Okay, what's this here? Objective function, correct? Yes? What is 48 and what is 40? Contribution of per work suit and per lounge suit. Okay. Now look at the diagram. Okay. Can you identify the points in the diagram? It says, on the diagram provided by the accountant, the accountant says OABCD is the feasible region. Can you identify? O, which is this, yes, understood? A, which is this, correct? Where's B? B, what else? C, yes? D is the feasible region. Yes, agree? Now, what are the lines? What are the lines? Well, diagram said earlier, right? This line here is the fabric, right? This line here is the tailor, this one here, right? Tailor, fabric. What about this line? Minimum of the what? Okay. Is it minimum or maximum? Let's go up again. Was it minimum or maximum? Are you sure? Look again. It says production of work suits should be less than or equal to 400. Is that a minimum or a maximum?
Maximum.
Oh, it's a maximum. Okay. All right. So, do you understand now? Let's go back to the diagram. Do you understand the diagram? Yes or no? You should by now. Yes? Which means what they're saying is the feasible region is what? Let me just shade it because otherwise, just to make sure that everybody understands. So the accountant says this is the feasible region. Sorry, just went out the line. Okay? And what else did the accountant say? The accountant says that what is the optimal point? B is the optimal point, it says. Yes? Okay. Can you calculate, based on this diagram and the information given to you, can you calculate the optimal plan? Yes or no? Yes. What will you do? Simultaneous equation. Which two equations? Which two lines intersect on B? The T and the F. Do you know which ones are they? Yes? Is it the T and the F? So, where will you find the T and the F? It's up on top, correct? Yes? Tell me, can you calculate? What is the, how many W and how many L will I make? Using simultaneous equation on point B.
these are the two you're going to use. Is that correct?
Yes.
2L. How many? 1,200. So, what should I do? I need to eliminate 1, correct?
Yes.
Yeah. So, let's say I will multiply T with, let's say, 2.5. Can I do that? It has to make it 5, correct? Yes? You can. Any number as long as you eliminate 1, right? Okay. So, what will happen? If I multiply that, F will be, still remain the same. 7W plus 5L equals 3,5. Agree?
Yeah.
Yeah. Then T will become what?
5W.
Okay. So it will be 5W because you multiply by 2.5 plus 5L equals 1. Sorry, no. Multiply by 5 is
3,000.
2.5 is 3,000. Okay. So which means what happens here? 2W, correct? 2, it will become 2W equals what? 500, or W becomes what? Okay, W is 250. Okay, so if W is 250, yes? Yes? So, what is L?
350.
So, L is equal to 350. So, that is your maximum plan, correct? So, what is our contribution? So, maximum contribution would be what? What should I do? Alright? Maximum contribution is, what is the formula again? C is equal to 48W plus 40L. Is that correct?
Yeah.
Okay. So if that's the case, using the maximum contribution, maximum plan is what? 250 and what? And 40 of what? 350. Correct? So did you get this one? So maximum contribution is what? 26,000. Yes? Right. So there you are. Did it ask you to calculate what is the maximum contribution in the requirement? Yeah? So it asks you optimal plan and maximum contribution. Yes? Did you manage to get that now? Okay. Now, let's go to B. Shadow price. But before I go to shadow price, I need to find out which one should have a shadow price. The fabric, the labor, or both? Okay, how do you know? How do we know? Does it say in the problem? What does it say in the problem? Yes, both are short supply, correct? But that is not the basis. And so both are binding, correct? Okay, so what you need to do is to put the W and the L, the 250 and the 350 in both equations, correct? If they are, what is the word? Binding, correct? Then what? If they are binding, what happens if they are binding? Oh, then you have to calculate shadow price. One at a time. Okay? One at a time. In other words, if you put 1 on hour, don't touch the material.
Yeah.
Yes? And in both cases, compare the contribution. Okay, do it. You better work on it, work on it. shadow price. I'm not calculating shadow price. I'm just putting your calculation. This one is what? This one is 5. Okay. So how do I calculate the shadow price of a fabric per meter? So I add what? 1 more meter, correct? So what is that? So in terms of fabric, correct? So this one, I will add what? 1 more, correct? Hmm? Sorry, which one? Which one? Am I wrong or right? Wrong. Which one is fabric? This one is ours. Okay, sorry. The other one is, this one is fabric? Okay. Okay, so this is wrong. Okay. So this is fabric, right? Agree? Okay, so, sorry. Okay. So this is fabric. I add 1 kilo. How about hours? So I add, no, at this point, because I'm calculating the shadow price of what? Of fabric. So the hours I don't touch. Yes? Not yet. Okay. So which means now, what will I do next? I solve it simultaneously, correct? Okay. So if I do that, what should I do? Okay. You want to make it 2.5 as well? Yeah, okay, no problem. So multiply by 2.5, it will become what? 5W plus 5L, okay, equals to 1201, correct? Yes? The next one remains the same. 7W plus 5L equals what? Sorry, wrong here. What should supposed to be here? That is 2.5. 3,000 to 200. 3,002.5. Yes? Okay. What about this one here? Would be what? 3,500. Okay. So which means after I calculated this, what happened? It would be what? Minus 2W equals what? Minus 502.5. So which means W would be positive, correct? W is equal to how many? 250.
Sorry, how many? 2? Okay, again.
497.5.
Sorry, here. What is it here?
-400.
Negative what? 400.
97.5.
97.5, sorry. Okay. And then which means W will be what?
248.735.
Are you sure?
48.75.
Getting confused. Okay, fine.
48.
$297. 248 point. Okay. All right. Then what will be L? What's happening to my computer? 248.75, correct? Plus 2L equals 1201, right? Which means L is what? Is equal to
351.175.
okay, so what will happen now to the contribution? C is equal to 48
W
W
plus 40
plus 40L. Okay, so what is the new contribution?
26,010.
26,010. Yes? Okay, good. Which means, what is the shadow price? How do I know? Okay, shadow price,
The new one.
price of, which one are we calculating here? Fabric per meter is, okay, what was the original? So new contribution is what? 26,010. Original contribution is 26. Yes? So shadow price is what? Shadow price is $10. Correct? You got that? Okay. Now, what will you do next? What's next? Shadow price of what? Okay, so this is $10 per meter, correct? Can you do the same thing for, tell me what is the shadow price for labor hour?
price for me? Labor? How much am I willing to pay premium? How much? 4. Very good. That is correct. It is 4. Okay? So, what should we do? The shadow price for, okay, let's add that. So if I put it bigger so you can see. Okay, so now let's calculate the shadow price for, what is it called? Tailor's hour, correct? Alright, so, which means, okay, where will I add 1? Okay, so, the tailor time, what is the formula of the tailor? 7W plus 5L equals 3501. Yes? Okay. Fabric remains the same. 2W plus 2L equals 1,200. No difference. Okay? So, what do we do next? We solve it, correct? Okay? So, similar to earlier, we multiplied it with 7.5, correct? So, it will be 7W 5L equals 3501. Then this one becomes what? 5, yeah. 5W, we multiply by 2.5 plus 5L, sorry, equals, what was it again? 3,000, 0,
3,000.
sorry, 3,000, sorry, because there's no one. Alright? Yes? Agree?
Yes.
Okay, now next. Which means, therefore, what will happen? 2W equals 501. Which means, W is what?
250.5.
250.5. Okay. Now, that's the case. What happens? Okay, so 7, 250.5, whoops, plus 5L equals 3501. L is how many?
L equals 349.5.
Okay, 349.5. Yes?
Yes.
Okay, so therefore, what is our contribution? Contribution? 48 of how many now? 250.5. I said, yeah, correct. Plus 40, 349.5. So our new contribution here would be how much?
26,004.
Okay, 26,004. Okay, so shadow price per tailor time, tailor hour is what? 26,004 minus what? 26, the original, equals US dollars 4. Correct? Yes?
Yeah.
We will not know what is the maximum price because they did not give us how much they pay per kilogram, correct? We will not be able to know. But we can know only the shadow price. You got that? Okay? The problem doesn't say how much do they buy the materials originally. Yes,
Does everybody understand how it's done? Can we say goodbye to this topic? Goodbye but not forget. Yes? Right. Goodbye to the topic but not forget. Okay? Again, we pass by the door. Again, this magic door really. Amazing. Okay? Any questions? Yes, question. E? Why E? Really? Vicky? How'd you get that? E is maximum. The problem with E is not within your constraint of your Taylor time. But it cannot be possible because you cannot produce it. It's more than the time that you need for Taylor. Try your combination and see how many hours you can get. To satisfy yourself. Your combination of you told me is the maximum. Yeah? You have a combination of W there. Yeah, which makes you 27, correct? Can you put that in the equation of the Taylor time? Check. Understand? Because your E is beyond the feasible region. It does not fall into the Taylor time constraint. So you see you need more Taylor time. Even if you say E is the highest possible, but yes, it is, but you don't have enough hours to make the E. Ideally, if they had more time, they could have been, right? So, let me share with you her question. Her question is, she said, oh, there's one more point, she said. There is, which is valid actually. Look, there's one more point. She said, what about E? Can you tell me what about E? Because it says, A, B, C, D is the visible region, correct? E is not included. Why? E is, yes, you have the fabric, but what is missing is the time, correct? Yes, E, fabric-wise, E is okay, but you don't have enough time to make that point. Yes? Right? Yes? She said, oh, but the contribution size, correct. But then, even if it's the highest, I don't have enough time to get to that. So I have to set them with what I have. That's why it's called a constraint. Good question. Next question. Right. So now, you know what to do, okay? Alright, good. No more question? So what are the important parts? I need you to understand the graph. I need you to know how to make constraints and objective function. Do you know that by now? Okay? So, do you know how to calculate shadow price? Do you know how to draw an iso line? Okay, you'll not be asked to draw. But if there's an iso line, what you can do is do a parallel line, correct? Or interpret. This one is easy for you to interpret, isn't it? Easy, yeah. Alright. I have some questions in the revision kit. Yes? In the revision kit. To be able to help you understand. Do you want more exercise? Yes or no? Okay, I have another one for you. Oh my God, there's more. Actually, there's more here. You remember the handout I gave you? Okay. There is something I want to show you. I think we solved this already. What I can do for you, because I have some questions there for you to do exercises, okay? Also, it is something asking you about shadow price, also about maximum, okay, optimal plan. Alright? I'll leave that to you to do it as an exercise. Alright? Okay? It's on your slide. Do you see it on your slide? There's a question. Yes, there's a black question here. Look for the question. Yes, question, production tips. So many things, so many exercises for you, okay? So, when you mark it, you can work on this problem. Number here. Okay, do you have this? Yes? Do you have the answer for this? No. Where is it? Wait. This one. Ferry Chewer Company. Do you have this? Can you look? Yes or no? Yes. Yep. It is page 9, slide 18. Okay? Page 9, slide 18 is something you can work on. And there are many more questions after that. Yes? Alright, so I'll leave that to you to exercise. I will send you the answers to these pages via Google Classroom. Alright? So, you have something to do. Slide number 18, page 9. Are you did already? Are you sure? Yes. You did it already. Sorry. Which one is the one we didn't do? Okay, so you have page 13. This one is the optimal plan if you have one constraint. Okay? So I did that. Okay, page 17. Page 17, slide 33. That's it. Page 17, slide 33. That's it. Okay, PHPLC. Do you see that? PHPLC. Okay? You saw this one? Oh, sorry, page 715. Sorry. Page 15. Slide 33. Slide 30. 29. Why is it different? What's yours different? Huh? So weird. 17 is another exercise. Why is two different things? 29. Okay, so it's the same, huh? Yeah. Okay. Alright? Okay, so I'll send you these answers via Google Classroom. Alright? Any questions? Alright, chapter 5. Pricing decisions. I will post it. This question is if we have answers on the cat and stitch. I have an answer. I post it on the Google Classroom, but I also will save on the OneNote. Okay, the one that we work on the screen. Okay, so you can have both. about in the decision-making area of the syllabus, you started with CVP analysis. Yes. We also now learn how to do linear programming or limiting factor analysis. Third topic, pricing. Pricing is a decision-making process. Yes? So, what would be the basis for making the decision? This is the topic now, chapter 5. Okay? Chapter 5 is pricing decision. Sorry, one second. I knew it was decision. Hold on, that's what I'm Okay, so, right, one of the things I noted in your comments was that the slides were too small the last time, so I tried to make it bigger. Alright, so here is it. Now, here would be different methods of how companies make decisions on pricing. Okay, so we will look at pricing and how, depending on the market, what type of demand, what type of competition or market you have. Okay, is it purely what do you call this? Perfect competition or oligopoly and stuff like that. So we'll need to know. Okay, does it affect pricing? What about demand and price elasticity of the product? Does that affect how pricing is decided? And how about if companies want to maximize profits? How do you determine demand and price and what gives us the maximum profit for a certain price? Because remember, if you increase price, the demand will fall, correct? Okay. If you decrease price, the demand will increase. So what combination gives you the maximum revenue? Okay, the terms maximum profit. Right. And the third would be other pricing strategies, like what marketing have. They have many kinds. Okay? I'll give you some examples when we talk about it later. Okay? So the first thing here is, let's look at, okay, number one thing that you need to know, what would influence the pricing. So I'll give you some way to remember what factors what factors influence price. So you need to be able to remember them because you may be asked to explain them, okay, in the exam. Right. Then we will look at price elasticity of demand. Okay, for those who've done marketing, they refer to this as the PED, price elasticity of demand. Okay. Alright? Then we look at, okay, straight line equation to determine costs and relationship of cost. Okay? Then, this is the next one. Optimum selling price and quantity for an organization when you have, okay, when MR, the revenue, marginal revenue, is equal to marginal cost. Okay? No, I didn't have mic. What happened to my mic? Mic died on its own. Okay, sorry. Here we go. Then, alright, we need to know, should the company increase production and sales level considering that there are incremental costs, in other words, relevant costs? Okay. Now, how do you, okay, determine price when you want to maximize profit, as I said? And of course, we look at different pricing strategies. Alright? And we look at the normal ones we know, cost plus and relevant costing. Although relevant costing, we'll have to talk about it in chapter 6, but we'll talk a bit of that here. Okay? Now, alright, so anyway, we talked about it already. Here, this is the chapter summary. So, pricing can be done using many different strategies, but one thing we need to look at is demand. Okay, the demand of the product, its price elasticity will determine. Okay, the elasticity will determine the price. Okay, or we look at the cost, which we know will determine the price. Right? We add the profit or the margin, then you get the selling price. Or you would get optimal pricing when marginal revenue equals marginal cost. I will explain one by one later. Okay? Now, look at this. Pricing decisions, they will ask you to do two things. Calculate and explain. Okay? In other words, you will be asked to calculate the price, and then they will ask you, is this the only thing that will affect price? What other factors affect price? So that's why you need to remember what factors affect or influence price. So they will ask you things like this. Okay? Alright. So let's start with the first one. Okay? Remember, the market will, okay, will determine your ability to influence price. Let me explain. There are different kinds of market. You have a market where you have perfect competition. Means all of the suppliers sell the same product and all the same. And there are some means there are many sellers, many buyers, only one product. Okay? Like the Russian market, right? Many sellers, many buyers, but everything looks the same. It's exactly the same, right? So you have the same scarf in 1,001 stock shops. Okay. Now, monopoly. One seller that dominates, but many buyers. Example. Which one? Which one? What's that? Ah, okay. So garbage collection. Can be. Well, one of the things you think about this time is garbage, huh? What about iPhone? Apple? Are they the only ones selling that? No. Oh, really? Is there any other company that says iPhone? Very cool.
Oh, you didn't.
Oh, yeah, I mean the iPhone. Yeah. Sorry? Yes, they have the same. There are other phones, correct? It's not really a monopoly, correct? It's a It's a monopolistic competition, not really monopolistic competition. Okay?
I buy the license from the export company and buy to sell for everybody, and then nobody can say.
Resale. It is the resale. Authorized reseller. Yes, could be. Yes, could be. Yes? Exactly, yeah. But there's one who can, it can be only one, no? And they can dictate the price, isn't it? Monopolistic competition. Large number of suppliers offer similar, but not identical. Example. Can you think about an example? You go to the supermarket. You want to buy shampoo. You know shampoo?
Yes.
Okay. Now, there are many shampoo, correct? But one says, I have these magical beads that make your hair shiny. Excellent. Then the other one says, I have these ingredients that makes your hair smooth. So based on whatever they're claiming, they can increase their price accordingly. But so there are different prices, correct? There is a competition, it's same shampoo, but they're not really identical, isn't it? Yeah? So it's monopolistic competition. There is a competition, but with slight differences, correct? And each one can command their own price, depending, of course, on how they sell, what is different on them. Oligopoly! Coca-Cola and Pepsi now, there's no more only two of them. There are many, isn't it? Yes, there are many things that that are against them. So it's not really an oligopoly anymore. Because they cannot control the price. Give me another one. Parang pizza. What is it? Pizza? Pizza company! Why do you talk about food at this time of the night? Huh? Yes. Yes, petrol companies. You understand? Petrol companies, it's not one supplier. There are many of them. But, they what? There are few of them. They compete with each other, correct? But then, they agree to sell at a regulated price. You understand? So they dictate. So they say, anyway, they will buy from us, so we will all agree to sell. It's called the petrol cartel. You understand? They agree to sell at a certain price. Okay? Now, what makes you go to one and not the other? Why do I go to Caltex, not to Total? Okay, can be. You understand? But the price is the same, right? Okay? Or, I would actually go to Caltex because when I go there, they give me bottles of water for every liter I buy. Something like that. You know, they have this campaign, correct? That's why sometimes you see a lot of this campaign. There's a raffled room, motorcycle, correct? But they cannot change the price. That will attract people to go to them, correct? Yes. What does Total do? Since we talk about Total actually, they don't do that, but they actually offer the service. Where you go there, before they finish your gassing up, they say to you, would you like me to check your engine? Okay? Do you want me to clean your windows? Or your screen and back and front? You understand? Okay? So things like that. So they will try to attract you in other ways. But the price, they agree to sell one time. One price. You understand? Okay. So that's oligopoly. So in terms of different types of markets, yes, if it's a pure competition, can any one of the seller change the price? Pure competition. Tell me, can any one of the seller change the price? Can? Pure? Yes, they can. So if they reduce, will you buy from them? Yes, they can. Right? They don't have an agreement, but they sell the same product. Okay? Now, how about, but can they really change? Can they increase? Because I don't, usually if I increase, I want it higher, not lower, correct? Okay. So, but I can make it lower to get people to buy from me. Right? But, okay, not really, they cannot change a lot. Otherwise, you understand? They will not be able to sell. In a monopolistic competition, okay, it's different prices. So they can actually charge different price within a certain range. Otherwise, if it's too expensive, people will not buy as well. Okay. How about in oligopolistic competition? Again, we said the price is agreed upon by the seller. Monopolistic competition, since there's only monopoly, no, in monopoly, only one seller. So who dictates the price? The seller. The seller can dictate the price that they want, correct? So the type of market affects pricing decisions. Okay? Now, other factors. Price sensitivity. Okay? Now, what is price sensitivity? If there's change in price, the buyers will not buy. Yeah? If they increase, they will not buy. Okay? If they decrease, a lot would buy. Okay? Alright? Price perception. So if people think that the prices will increase, what will happen to the demand today? Will increase. You understand? They will perceive that the prices will increase. They will start to buy now. Okay? In my country, they announce tomorrow. It says there will be a price hike of the petrol. In other words, it will increase. You know what happens in the petrol station tonight? Yeah, and stupidly enough, I'm one of them who actually line up there. And my husband told me, "Where are you?" I'm lining up in the gas station. Why? A price increase tomorrow. It's crazy. You put tomorrow, you still have to put again when you finish the gas. So why suffer now? So, you understand? Okay. So I will not line up again. It only happened once. Okay. Compatibility with other products. Okay. Now, all right. So what happens here? Like example is operating systems on computer. Okay. All right. So if it's compatible with other products, what happens to its price? Okay. What happens to the price? Will it affect price? Will it become higher or it will become lower? You sure? Yeah. For example, I'm selling something that is compatible with, let's say a car part. It's compatible if I use that in Toyota or Honda. So what do you think? Higher because then the company and people can buy it and applies to everything, correct? How about competition? Will it affect price? Yes, of course. We don't have to explain that. How about competition of substitute products? Yes, okay. So it will affect the price. How about suppliers? Can suppliers affect pricing? Of course, because if suppliers will sell you the raw materials at a higher price, you have to increase your selling price, correct? Because your cost increases. Okay? So, inflation? Yes. Okay. Inflation. You know what's inflation, right? Okay. The prices will reflect the increase in supplies. How about quality? Can quality dictate price? Yes. You know why? Even if my product is costed lower, I could actually sell it lower. But you know what happens? If you sell something at low price, customers perceive it as what? Low quality. So you have to increase your price a bit so that they will not think that your product is low quality. You got that? Okay, so quality can, or really, sometimes quality can dictate price. Because really, to be quality product, you have to have quality materials, quality labor, correct? So what happens there? If you pay for quality, your cost also will increase, correct? Incomes. Whose income? The buyer's income. Yes? Which means if the buyer's income rises, what happens to the price? Is price really important or they would go for what they like? For what they like. Price is no longer an issue, isn't it? Okay? So if incomes generally in the economy is good, so you can actually price your product at a higher price, correct? Now, how about ethics? You have a moral obligation. If you are selling something that is a commodity, like rice, yes, and you know that rice is short supply, so you know what we said earlier, if it's short supply, you can increase the price, isn't it? But it's your moral obligation not to increase so high that people will not be able to buy. Okay? People will be dying of hunger but cannot buy rice because it's too expensive. It's really not, cannot be bought. Now you have a moral obligation not to increase the prices so high of something that people need. Rice, sugar, flour, salt, you understand? Things that are needed by people. So that's an ethical or moral obligation. Okay? So that also can affect prices. So, how do I remember all that? Okay? Some are here of what we talk about. So, what did I put here? Picnic pies. Picnic pies. Again, at this time of the day, it is food that we talk about. So you will never forget picnic pies. Okay? So we talk about inflation, we talk about competitors. How about this one? Newness. What does it mean? Newness of the what? Of the product. It's something different, something new. You're the only one who has it, right? You take it, right? Right? We talk about income, we talk about quality, we talk about price sensitivity. Oh, this one, we didn't talk about this. Intermediaries. Who is this? When you say intermediaries, is the what? Correct. The intermediary is between the producer and the buyer. Yes? So do they also add their part? Yes, so they will have to affect the pricing eventually. Yeah? Right. So intermediaries will also influence the price. Okay? And suppliers will talk about. So picnic. Oh, sorry, there's one more. Product range. Will the product range dictate to me the price? What does it mean, product range? What I'm selling, isn't it? Okay? Yes? So, for example, I'm selling printer and cartridge. Right? So this is my product range. So can I sell the printer at lower price, but the printing ink to be higher? Yes or no? What do you think? Can I do that? I'm a seller of a printer and the ink. So what will I do? I will try to sell the printer at very high or very low price? Very low price. Where will I get my profit back? When you come back and use the consumable, buy the ink, buy the ink, buy the ink repeatedly, correct? Product range. Or, okay, so whatever is your product range, you price it accordingly. There are more examples later on. So picnic, price. Okay? Picnic, not with a C, but with a Q. Okay? So remember those. Those are the factors that influence price. Okay? Another thing is demand. What does this chart tells us? What does it say? When the demand increases, what happens to the price? Again. Demand and price. What is that? When the demand increases, what happens to the price? Increase or lower?
Increase.
You sure? When the demand increases, sorry, you don't know how many. I understand at this time of the night, and is hungry, you don't even know what is left or right, isn't it? Okay. So you have what? This is your demand, this is your price. So when the arrow goes to the right, means increase, correct?
Yeah.
Okay. So what happened? If your demand is low, the price is high. Or when the price is high, maybe, the demand is low. Or when the price is low, the demand is, okay? So demand increases when prices go lower.
Agree? Okay. You agree with this or no? Yes? Okay, you have to agree, otherwise we'll not go home tonight. Alright. What?
Depend on which one the example demand.
Can be. Isn't it? Okay. Yes, sometimes there is a product you want to buy, the prices is lower than you actually go and buy, correct? Okay. But there is also, when the demand is high, what happened? Or the other way around? Which one? Yes. Can be. Alright. So that's where we talk about price elasticity of demand. Okay? Price elasticity. So here, demand is an important factor to influence price. Okay? If the demand increases as prices are lowered. Okay? Will the prices decrease if demand increases? Example. Give me an example. Huh? Food? He says, iPhone, he says. Okay, but the iPhone, the demand increases if the price decreases. Agree? Yes. But what she's saying, how can be that how can because here he said, the demand will increase if the price will increase. Okay? What happens here, he says, what happens if the price decreases? Will the demand increase? Yes, iPhone. Yeah. How about if the demand increase, will the price decrease? Correct. The demand increase if the price decrease. Agree. That's what he said in there. She's saying, what happens if the demand increase? Will the price decrease? Yes. Example.